All right, here we are, lesson 6.2, radicals and rational exponents. All right, so we're going to be finding nth roots, and we're going to be evaluating expression with rational exponents. Okay, so this is a lot of words. I know this is out of your textbook, and we're going to take our time and kind of go through a couple things here. So when we have the square root of something, right? When we have the square root, say, of 25. We know that this symbol means to take the square root. What you may not understand is that right here is an assumed 2, right? Because there's parts to the root. And here, n, and this is a, all right? Right here, they call this the index. So we can have more than just a square root. We can have a cube root. We can have a fourth root. We can have a fifth root, all right? So what this is saying right here, since the square root of 25 is 5, it is basically saying that 5 squared is equal to 25. All right, it's bringing up this relationship. So in this example, they're talking about a cube. It says, for example, 2 is the cube root of 8. Okay, so 5 was the square root of 25. 2 is the cube root of 8 because 2 cubed is equal to 8. So what does that look like? We have the cube root of 8 would be this, right? And we could evaluate that to be 2. It says 3 is the fourth root of 81 because you have 3 to the fourth is 81. So the fourth root of 81, that's how you would write it. You just change the index. Notice that the index is now what the exponent is. Okay, of the actual root, the exponent of the root. How would we indicate, though, with an exponent that we wanted 5, right? Um, from 25. When we're talking about roots, what we're getting to in this lesson is that we're able to use a fraction, like a half. So if we take 25 to the 1/2 power, that is your rational exponent. What this means is you're actually taking the square root of 25. And of course, I didn't need to write the 2, okay? That's what it means, all right? Because 25 raised to the 1/2 power would be equal to 5. And we'll get to more of that. All right. So when we're talking about integers n, when we're talking about the nth root of a, can be written like this. The nth root of a is written like this. You have the expression, it's a radical, n is called the index of the radical. We can write an nth root as a power of a, okay? And that's with these rational expressions. So a to the 1/2 is the square root of a. A to the 1/3 is the cube root of a, and a to the 1/4 is the fourth root of a, okay? A to the 1/2 is a number whose square is a, so you can rewrite it. I know it's very confusing, but you have to think about this as the general term right here. The nth root of a can be written, and now you take what was underneath there, okay? The a to the 1 over n power, and the n, it becomes the index, all right? And this is for n, integers n greater than 1. So we're not talking about any negative indexes. We're talking about, greater than 1 for n, and then we'll talk about some different values of a. So if you're a little bit confused, it's okay. Remember, that's part of the process of learning, and I'll walk you through it. So let's go through step by step, and I'll do some examples. It says, let n be an integer greater than 1, right? And that's going to be the nth root. And a is a real number, right? We know what our real numbers are. Okay, good. Real numbers can be, rational or irrational, but we're going to be dealing with rational numbers right now. All right. So we have n is odd. If n is odd, that could be 1, 3, 5, 7, whatever. And then a has one real nth root if n is odd. So that could be this, like cube root of 8. What is that saying? That is saying n is equal to 3 and a is equal to 8. And this is their places, right? This could be written as 8 to the 1/3 power. There's only one solution. There's only one answer to this, and that answer is 2, okay? Um, in order for us to indicate that we want the -2, we would have to change a to be a negative. So when you have an odd index, you can have a negative underneath the radical symbol. So the nth or the third, the cube root of -8, right? That's like saying -8 to the 1/3 power. And now this answer or solution is equal to -2. That's how we get our -2. But it's very different than when we have the square root. And you may have when you have n is even, right? And the easiest one that we do is like, n is equal to 2. And we just kind of did this before. A was equal to 25, right? So we're saying the square root, and this is like the principal root. That's why we don't have to write the 2. It's like writing an exponent of 1 for every number. We don't do it, right? So the index is even, it's 2, it's a square root. This is like saying, but what we can say is that we have this positive negative because there's going to be two roots when um, we have two real roots. That's what this is saying. Positive, negative, because n is even. This is the same if you do the fourth root or the sixth root or the eighth root or whatever. There will always be two possibilities, two possible solutions. So this is like a plus or minus 25 to the 1/2, right? And the solution to this is plus or minus 5. And the reason that is because 5 times 5 is 25 and -5 times -5 is also 25, all right? What you will not have is you will not have a negative with, a negative a with a even index, all right? That's not gonna happen. All right, so what if we have an even index and a is equal to 0? So n can be equal to 4 and a is equal to 0. So the fourth root of 0, right, is always going to be 0. So it always has just one real solution, and it's always 0. All right, here's where we have n is even and a less than 0. This is where a is going to try to be negative. So if we had n equal to 6 and a equal to -3, and we wanted to try to take the sixth root of a -3, and it doesn't matter what this index is, as long as it's even, you will not have a negative underneath there. We start getting into imaginary numbers. It is not part of the real number system, and you will deal with that in a couple years, in high school. But as of now, the only time we'll see a negative underneath the radical symbol is with an odd index. So keep that in mind, and then we will get a negative solution. With an even index and you know, a greater than 0 underneath the radical symbol, the root, we'll get both positive and negative. So we're going to be working on this and kind of going through and working these out. All right, let's take a look. So if n is 3 and a is -27, we have the cube root of -27, which means we want the -3, sorry. So we're just going to find the indicated root, right? This is what we're evaluating, -27 to the 1/3 power. That's what that is. If n is 4, a is greater than 0. So 16 right here has two possible roots from the last slide. So we know that we're either going to have a positive and -2, positive or -2. So let's try some. Okay, oh, I did want to point out, as you're evaluating these, look on your calculators, and here's that y to the x button here, and you're going to be using the second feature. And over here, I believe that's the square root right there. This is x squared square root. So this is called a caret when you're trying to get like a power of something. And say you want like 5 to the 4th power, right? So 5 to the 4th power, you would, and you're trying to evaluate this, you're going to be putting in the button, 5, and then the caret, and then the 4, and then that'll evaluate it. 5 to the 4th power, that's like using the y to the x. that's 625. So if you're wanting the fourth root, so then that equals 625. So now if we want the fourth root of 625, we know that's going to be equal to 5 or plus or minus 5, really, because it's be plus or minus to evaluate it. The answer is plus or minus 5. Then you activate the second feature. So these are both using the second feature, and that's how you can change the index and get the to evaluate these. And I'll help you with those a little bit more if you need it. Okay, so on this one, we have n is equal to 2, right? Do we need to write that? No, we do not, but I just did. So it's really like this, 64. We know that it's going to be plus or minus because n is even. A is greater than 0. So when we take the square root of 64, we can get plus or minus 8 as our solution. So I want you to evaluate and find the indicated nth root or roots of A for number 2. Go ahead and do that. Pause the video. And I'll continue. Since n is 4, we want the fourth root of 256. Since it's even, we're talking plus or minus here. So when we have plus or minus, we want take 256. So you would you can use your calculator to evaluate. We're wanting to know what time, what is a factor 4 times? And the answer is 4. So plus or minus 4 is the answer. Okay. All right. Now, all we're going to be doing is evaluating. All right. So we have let's see, cube root of -8. We have the opposite of the cube root of 8. We have 16 to the 1/4 and -16 to the 1/4. So looking at A, okay, cube root of -8. This is what it means. You have -2 times -2 times -2, right? So -2 is the value. So when you use your calculator to evaluate the cube root with an index of 3, here, positive is underneath the radical, okay? So it's like taking the answer of the cube root of 8 is 2, and this one singular negative sign is like taking the opposite of that. So both of these are two ways to show a -2 solution, okay? And then here, when we have 16 to the 1/4, that's like taking the fourth root of 16, all right? And the answer is a positive 2. And then trying to take the fourth root of a -16 is not allowed because the index is even. You cannot have a negative underneath the radical. So it's not a real number. I just crossed it out when I meant to underline it, but you get the gist. All right, here we go. So I would like you to work on these. Let's see, evaluating the expression. So we want to take the fourth root of 625. So again, in your calculator, you would, so now it's telling you, right? It's kind of actually not just telling us how many roots there are, but because there's no negative out here, it definitely means it wants the positive root or the principal root. And the fourth root of 625, so if you put in 625 in your calculator, and then you hit your second feature and your uh, function on the calculator that would get, it's waiting for x. So I would do 625 second y to the x, and then it's the 4 is the x, and the answer is 5. So it's a positive 5 because there's no negative sign outside here, okay? Here, we want the cube root of a negative. This is odd. The index is odd, therefore we can have a negative underneath, which means that our solution will be a negative, right? And so you can put in 512, you can put in -512, however you want to deal with that negative, but you understand that the answer will be negative. 512, second feature, and now it's waiting for that cubed, and so -8. -8 is the cube of -512. Okay, here, I'm going to do number 12. I want you to do number 11. Please evaluate number 11, pause the video and indicate your solution. I'll work on this one. So this rational is 1/2. Actually, I'm going to work on this now. And then I'm going to pause the video and let you do 11. So I will work this example out first, and then you will do number 11. So sorry for all those extra words that made the video extra long. So oops. All right. So here we want the square root of, and it says negative 81, because 2, or the square root, principal root, is an even number, right? We cannot take an even root of a negative number. So there is no real number here. All right. So remember, when you have this rational exponent, that the denominator is the index. All right. So with that knowledge, pause the video and do number 11. All right. So here we are with our rational exponents again. So we have a to the 1 over n is the nth root of a. Fun. Always fun. Now we're going to take that and we're going to bring back those exponent rules. Remember that if we take, um, you know, a to the 1 over n and we times it by m, we're going to get a to the m over n right there, okay? And we can simplify this right here, because this is what this is right here. And we can say, okay, we know the denominator is the index. The denominator is the index. Then, right, it's like taking, so you have the indicated nth root of a and then raising it to a power to evaluate it. So let's look at this one. Let's look at the numbers. You have 2/3, right? That's like 1/3 times 2. So you take the cube root, because that's what the 1/3 exponent means, the cube root, and you're going to take your answer and you're going to square it. So if we evaluated this, the cube root of 27 is 9, right? We have 9. Mrs. Kleinman, we have 3 times 3 times 3. The cube root of 27 is 3, not 9. I don't know where these things come from in my brain. I really don't. I just don't. Okay. I think maybe my brain thinks factor, 3 times 9 is 27, and then I just say random stuff, but I don't mean to. I apologize. All right. Whew. So the cube root of 27 is 3, all right? And so we have to take this 3 and square it. I think also the answer is 9, so maybe that's why. So that's what the indicated root is. So when you take 27 to the 2/3 power, you could also use your y to the x button and put in a fraction using the ABC button. So that's kind of fun too. So if you did like 27 y to the x, and then you did 2 ABC 3 power, oh, that is so cool. So using all the functions on your calculator, and if you need more, ask me. All right, so we're rewriting this. Basically, that's the gist of this example. So here we go. We want to evaluate it, right? So we have 16, it's going to be to the 1/4, and then the whole thing raised to the 3rd power. So you're going to take the 4th root of 16, which is 2, and then take 2 and cube it, which is 8. For 27, we have 27 to the 1/3 power times, or to the 4th power, taking that whole thing to the 4th power. So we're going to have 3 to the 4th power, or 81. All right, so we get to do some. All right, we're going to rewrite it as a rational exponent. So we're going to be working backwards now. So remember that we said that n is the index and n is the denominator. So we can rewrite this to be 3 over 5. Okay, that's 4 to the 3/5 power, 4 to the 3/5 power. Okay, here, because my index is odd, I can have a negative underneath here. Always double check. If that's even, no negatives, right? No real numbers. But this becomes the denominator and this is the numerator. So I have -8 to the 2/3 power. So go ahead and pause the video, and I would like you to rewrite number 15 with a rational exponent. That's all we're doing, is we're putting it in rational exponent form. For number 16, we are going to rewrite it into radical form. So let's write the radical form. We have an odd index, right? So we have the 5th root of the -3, and that's allowed, and we're going to square it. So the 5th root of -3, that's coming from the denominator, which is the index. All right. and we're just rewriting. At this point, we're not evaluating, okay? So for this one, I'm going to have the square root of 6, and then I'm going to cube it. Okay, the square root of 6, and I'm going to cube it. So I would like you to pause the video and give me the radical form of 12 to the 3/4 power, 12 to the 3/4 power. Awesome. Okay, in this example, we are now getting to the point where we're going to evaluate. Let's evaluate. So we have 32 to the 2/5 power. So that means I have the 5th root of 32. And then I'm going to square it. So the 5th root of 32 is 2. 2 squared is equal to 4. Okay. For number 20, I want to take the square root of a -64 and then cube it. But my index is even, my underneath the radical is negative, and this is not a real number. So not a real number. Okay. Pause the video and evaluate number 21 for me. All right. Last problem, real life application of when we use things like this. So we have the radius of a sphere given by this equation. So what this means, right? This means that we're basically going to rewrite this. Okay, A is the surface area of the sphere, and the surface area is 1,493 square meters. We're going to find the radius of the sphere to the nearest tenth of a meter, and we're going to use 3.14 for pi. So R is going to be equal to, and so this 1/2 means we're taking the square root of A over 4 pi. So that's equal to the square root of 1493 over 4 times 3.14, square root of 1493, and this is 12 point, my brain can't work that fast. I'll see it and I'll be like, oh yeah, 56. Yeah. School bells ringing, all kinds of stuff going on. All right, at this point, because we are going to be approximating it, right, you can divide that. So if I did the 1493 and I divide that by the 12.56, I'm going to get, oof, it looks like 118, and then we have 0.8694268. And I'm going to take the square root of that, and then I'm going to approximate it and round it to the 10th. So don't round it before you take the square root. You can go ahead and divide this, keep that long decimal in your calculator, then take the square root of that number, and we'll get approximately 10.9 meters is our answer. So you should be able to work that out and get something like that. So be sure to ask questions if you have any related to this video.